Good morning, happy Friday. Obviously I'm not here again today. Unfortunately, I have some sick kiddos. So since I am not here to explain the notes to you, the next best thing is me making a video. Hopefully the substitute has collected the mountain math worksheet. I will be grading that. And hopefully you have gotten your notes out of the red folder at the front of the room. You will be filling in those notes as I walk you through them. So if you look at the top of your notes, you can see that we're going to start talking about graphing linear equations. Well, the first thing we need to know is, what is a linear equation? Hopefully you realize this word line right here. Okay, a linear equation is okay, so if it's linear, when you graph it, it will be a straight line. Now there's several different forms that we'll talk about, okay? It's kind of like when you have a fraction form versus decimal form, okay? We have something called standard form for a linear equation. It looks like this. Okay, so standard form looks like ax plus by equals c. Ladies and gentlemen, a, b, and c are just numbers. They have to be whole numbers, and they need to be greater than 0. Okay, so that's what it'll look like. The a will come first with the x on it, the b will come second with the y on it, and then it equals the constant on the end that has no variables. Well, if it's linear, there's also something called nonlinear. And how do we know if they're nonlinear? Nonlinear equations could have these things. They could have exponents. They could have square roots. They could have division by a variable. Division by a variable. Or they could have multiplication of 2 variables. So if an equation has any of those things, then it is considered nonlinear. So the first thing that we're going to do is we're going to decide if these things are linear or nonlinear, and then if they are in standard form. Well, if we look at number 1, that almost looks identical to the standard form that I just wrote. Remember, standard form is ax plus by equals c. Okay, in this case, the a is 2, the b is 5, and the c is 2. Okay, so this is a linear equation, and it is in standard form. Okay, so there you go. It is linear, and it is in standard form. Okay, let's look at number 2. Okay, number 2 kind of looks like standard form, but we have an issue. We have division by variables, so automatically this is nonlinear. Okay, and if it's nonlinear, we can't put it into standard form anyways. Okay, so that's it. We just label that as nonlinear, and then we're finished. Okay. All right, number 3. Now you'll notice this time we still have some more division, but this time we're not dividing by variables. Okay, they are being divided by numbers. So this thing is linear. Now, right now, it's not in standard form. Okay, so this is non-standard. Okay, it does not look like ax plus by equals c because of the division by the 4 and by the 7. So we can manipulate this. Okay, if I multiply this entire thing by a whole number, I can eliminate the fraction. So 4 times 7 is 28. So if I multiply the entire thing by 28, I can turn this into standard form. Okay, well please note that there's a 1 in front of that x, so it's really 1/4. So in your calculator, you'll type, well, maybe I'll just rewrite it. 1/4 x plus 1/7 y equals 1. Okay, now if I multiply the whole thing by 28, the entire thing, this will be 7x plus 4y equals 28. And now it's in standard form. Okay, if we look at number 4 over there, hopefully you notice right off the bat this thing is nonlinear. Okay, we have exponents, so automatically it's nonlinear. Okay. Going on to number 5 here. This doesn't have any of the things that we mentioned. There's no division of variables, there's no exponents, there's no square roots, there's no multiplication of two variables, so this thing is linear. And right now, it's in non-standard form. This does not look like ax plus by equals c, but I can get it to look like that. We know that the x's are supposed to come first on the left, so let's move all the x's to the left. If I move this x, those end up canceling out, and I get y equals negative y. Okay, well I don't have any x's. Now how about the y's? I also need to move those over, so they're on the left. So I'll plus y to both sides, and I have 2y equals 0, because those will cancel. Well, this doesn't quite look like standard form because there's no x's, but I just said no x's. So we can rewrite this to say 0x, so now it's in standard form. Number 6 is going to be a pretty quick one for us because I have x times y. So automatically, that is nonlinear. Automatically. Number 7. So far, I think it passed the test. We don't have any division of variables, no exponents, no square roots, no multiplication of two variables. Okay, so I just need to get this thing into standard form. This thing is linear. Well, in order for this to be in standard form, the x's have to be out front and come first. So let's move those x's over. Notice I did not combine the x and the y's because it was being added and they are not like terms. So there we are. That thing is now in standard form. Okay, looking at number 8. There's no exponents, no square roots, no division of variables, no multiplication of variables. So it looks like I don't have any x's. Okay, so we'll label this as linear because it passed all those tests. Now there's no x's, so I'm going to go ahead and write that in there. So I'm getting it into standard form. Now my issue is I've got a 1/3 right there. Well, in order for me to cancel that out, I'm going to multiply everything by 3. So I now have 0x plus y equals negative 3. And now we're in standard form. Okay, moving on, number 9. Oh, this one's no good. Right here, I've got multiplication of two variables. So this thing is nonlinear. Okay. Number 10. Well, there's no multiplication of variables. There's no exponents. There's no square roots. And there's no division of variables. So I think we're safe here. This thing is linear. But I need to get it in standard form. So the x's come first. I need to move the y's over now. Notice I cannot put the x's with the y's, so we write them separately, and it looks like that. But I still have that 3/4. Remember, all of those need to be whole numbers. So we're going to multiply the whole thing by 4. And when you do that, we get our standard form. Okay, one more over here. I think it passed all of our tests. I do think this is linear. I just have to get it into the right order. So we'll move the x's so they're together. And look at that. We have the x's, then we have the y's, then we have the equal signs, and then we have the constants. So now that thing is in standard form. Okay, so that's the first thing we talked about today, and that will be the first section in your homework today. The next thing we're going to talk about are x and y intercepts. Well, I hope you know what an ordered pair is. We've talked about this before. An ordered pair is just a point. And you know if it's a point, it has to say x, comma, y, and be in parentheses. Okay? You also should be able to tell me what a y-intercept is. and what an x-intercept is. Okay, so hopefully those definitions look familiar to you. Now, if I have something, and you don't need to write this, I'm going to just put this up here on the board. If I have something that is on the y-axis, so maybe I'll do this, and I have this point right here. Well, what is that coordinate? If I say x comma y, it's x comma y. What about this one down here? If I say x comma y, it looks like that. So hopefully you see a pattern here, that all of the y-intercepts have x equal to 0. So all of the y-intercepts will look like 0, comma, and then some y. Now, I hope that you can see that the opposite is true for x-intercepts. If I look at this point right here and I go x comma y, it looks like that. This point out here, x comma y, looks like that. So all of the y's are 0 for the x-intercepts, and they will always look like an x comma 0. So you're going to need to know that, okay? This right here is very important, okay? All right, so let's look at the back of your page now. Can you tell me what the x and y intercepts are? Okay, well, since I have to do 2 of them, I'm going to say the x-intercept, and I'm going to say the y-intercept. And I want you to physically put a dot on your page. Where does it cross the x-axis? Right there. Can you tell me that coordinate? X comma y. So x comma y. Now the y-intercept is where it crosses the y-axis. Please notice up there, guys, it says f of x. Remember that f of x is the same as y. Okay, so my y-intercept looks like that. And we're going to go through and we're going to do this for all of these problems. There's my x, 1, 2, 3. There's my y, 1, 2, 3, 4, 5, 6. Let's see, oh, I already got the points there. 1, 2, 3, and 1, 2, 3. And last but not least, 1, 2, 3 again, and just 1. Whoops, I put those in the wrong spot. Sorry, guys. All right, so hopefully that is just okay with you looking at the graph. All right, well, what if you don't have a graph? If you look at these problems, all I give you is the equation, okay? You are supposed to graph the following linear equations by finding the intercepts. So they should be lines because it says linear, and you need to find the intercepts and then graph them. So let's start with the x-intercept. Well, from the front of this page, I told you that every single x-intercept has a y that is equal to 0. So if I put in y equals 0, my new equation looks like this. Well, what's negative 3 times 0? It is 0. So that portion has canceled out. And the only thing that I have left is that. And hopefully this is a very easy equation for you to solve. Okay, but I need an ordered pair. Remember, ordered pairs are x comma y. So I have my x comma, and remember what my y was. It was 0. Okay, if I plot that point, 1, 2, 3, 4, 5, it'll be right over here. That's my x-intercept. Let's do the y-intercept now. Remember what I wrote on the front for every single y-intercept. The x is 0. Well, if my x is 0, it looks like that. Well, 2 times 0 is just 0. So this is now all that I have left. Another easy equation to solve. So y is negative 4. Well, I need an ordered pair. My x is 0, my y is -4. So if I go to 0, 1, 2, 3, 4, that will be my y-intercept. And I will then connect these dots and make my nice line. Okay, so we're going to go ahead and we're going to do this for the rest of these problems. So next up, number 2, x-intercept. We know that every x-intercept has a y that's equal to 0. So if you put a y that's equal to 0 in there, it looks like that. Well, 2 times 0 is 0. There's my new equation. Solve it by isolating the x. And x is 2. Well, I need an ordered pair. X, comma, y. 2, 0 is right about there. Okay, now I need the y-intercept. Well, every single y-intercept has an x that's equal to 0. So my equation looks like that. -5 times 0 is 0, so I don't really need it. And this is my new equation. Divide both sides by 2, and y is equal to -5. So my ordered pair is x, comma, y. And there's my y-intercept. We will draw a line through these two, and there's your graph. Okay. Moving on to number 3. Again, we go x-intercept and y-intercept. Every single x-intercept has a y that's 0. Well, if the y is 0, then this part is 0. So it just says x equals 5. Well, if you look at that, it's solved. The x is already isolated, so my ordered pair is x, comma, y. Looks like that. The y-intercept has an x of 0. Well, if the x is 0, this part cancels out. And I just have -y equals 5. Well, in order to solve that, you should realize that there's a -1 in front of there. So we have to divide by -1. And I get y equals -5. Ordered pair will be 0, -5. And there's your linear or line graph. Okay, moving on. Next up, number 4 here. So I want to find my x-intercept, which means the y is 0. If the y is 0, this part is 0. So it literally looks like this. So I got to have a placeholder over there. Okay, so now how do I solve that? And x is 0. So if you look here, my ordered pair is going to be 0, 0. Looks like that. Okay. And if I do my y-intercept, my x is 0. So this part cancels out. And I just have y equals 0. Well, that's already solved. So my ordered pair again is 0, 0. Well, I can't really draw a line through one point, so I got to find another point. Okay. Well, pick any x value you want. Seems to be easiest to me is just to pick 1. If I pick 1 as my x value, it says this. Well, you can make a point out of that. What was the x that you plugged in? It was 1. And the y that you got was that. So your point will be 1, -2. And now you can draw yourself a line. Okay. Next up, if I want to find my x-intercept, that means the y is 0. Well, lucky for me, I don't have any y's here. So I just get to leave it like it is. Solve, and x equals 5. So my ordered pair is x, comma, y. Right over there. Okay. Next, the y-intercept. That means the x has to be 0. Well, if the x is 0, I get this. Well, 0 doesn't equal 10. You all know that. Well, remember what happens when we get a false statement. This is no solution. There is no y-intercept. So what's the only way to draw this line so it will never touch the y-axis? The only way that I could possibly draw that is vertical, so it will never touch the y-axis. All right, one more for us here today. If I want to find my x-intercept, the y has to be 0. Well, if the y is 0, it looks like that. There's no variables left. And that's a false statement. So there is no x-intercept. Well, let's do the y-intercept now. For every y-intercept, the x equals 0. Well, there are no x's up there. So you just get to leave it the way it is. And the y is already solved. So if we go x comma y, it looks like that, which is right here. So what's the only way to draw this line so that there is no x-intercept? Well, the only way to draw that is horizontal. So it never crosses the x-axis. Okay, I hope you got all those filled in, copied down. The substitute should have a worksheet for you to do for homework once you finish this. And you need to make sure you complete that entire worksheet, and we'll start back on Tuesday since you do not have school on Monday. We have a teacher in service. I hope you have a good weekend, and I will see you next week.